she's frustrating me. She's frustrating me. She's doing the Dr. Mercola. She's proving carnivore is right, and then she's saying it's wrong. She's like proving that glucose is the main fuel source, and then she's proving that it's not. Glycated. Sugar. Where are you going to get that sugar? That's right. You get sugar. What is sugar? Oh, wait. She'll spell it out for us real quick. Sugar equals glucose. So why would you be using glucose as your main fuel source? You just said over here, it's not healthy. All right. So in this video, we're going to be reviewing somebody by the name of Scientific Snitch. Once again, if you're interested in making content requests or anything like that, go join my Discord. Link is in the description. Yeah, you go put it under content request. That's usually like the quickest way to get a content request thing out of me. I just usually put that on the review videos playlist, which this one is. So yeah, go join the Discord. Let's get to it.
Everyone is obsessed with blood sugar and insulin resistance causing all of their problems. But do you actually understand what insulin resistance is? Welcome to Noob Novice Nerd, where I explain topics on 3 levels of understanding. And today I'll be explaining insulin resistance. Noob level. In your body, the main form of fuel for your cells is sugar, which is scientifically known as glucose.
No, not true. The main fuel is not sugar, actually. It's not glucose. And we know this because when you, in this case, when you give your cells tons of sugar, they develop insulin resistance. And why do they develop insulin resistance? Because they're constantly, one, when you bombard your cells with insulin, you also prevent or inhibit autophagy. And in this case, inhibiting autophagy is a really big deal. Now, I'm not gonna get too detailed yet, but I will say that no, the main fuel source is not glucose. Your body doesn't want to be using glucose as its main fuel source. And if it did, it would produce all the glucose that it needs through gluconeogenesis, but it does not. Your body doesn't usually like that, actually. For most tissues of your body, they actually like ketones, especially your heart, by the way, and your brain. Your brain and heart absolutely love ketones. They're addicted to them.
Now, insulin and the insulin receptor act as a lock and key system to allow sugar into your cells to be used as energy.
Forgot to say, I'm going to have to rewatch that. But if you're interested in all the details behind everything I'm saying with all the sources referenced, go check out the Real Nutrition Science playlist found in my homepage. There are a lot of sources. That took a long time. So if you're interested in everything that I'm saying here, go check that playlist out. All right, time to repeat what you said.
The insulin receptor acts as a lock and key system to allow sugar into your cells to be used as energy. Insulin is a hormone which acts as the key which unlocks the insulin receptor, the lock, and once unlocked, the insulin receptor tells your cells to open up channel molecules on the cell membrane which allow sugar to flow into and fuel your cells. Now, unfortunately, due to genetics and living an unhealthy lifestyle, the insulin receptor lock can become rusty and damaged, which causes the insulin key to no longer function to allow sugar into the cell.
All right, so she said this part right here.
Molecules on the cell membrane, which allow sugar to flow into and fuel your cells. Now, unfortunately, due to genetics and living an unhealthy lifestyle...
Okay, so she said due to genetics and living an unhealthy lifestyle. So I'm going to say, one, if you ever blame genetics for this stuff, you need to be, tossed out. Get out of here, okay? No, genetics is almost never a big role. This is one thing I really don't like, and I'm going to say right now, if you pin something on genetics, you better have a really damn good reason why. Because everybody, and I don't know if you've noticed this, but that has been the scapegoat for almost every single problem. I can't begin to describe how many problems people say, oh, well, it's just in the genetics, right? It's just genetics. It's just genetics. Oh, arthritis must be genetics. Oh, malfunctioning kidneys must be genetics. No, okay, this is not genetics. You can get rid of almost every single one of these problems if you eat correctly. But if you don't eat correctly, one, two, also if your environment is pretty poor, like you don't have correct sleep, microplastic exposure, tons of other things. If you're interested in all the details, go check out the Min-Maxing Health playlist found under my homepage. Once again, it'll tell you how to min-max your health. If you're blaming genetics, honestly, you need to be thrown out the window. Get out of here. That's not how it works. No. And living an unhealthy lifestyle. So I'm looking for the source, which says unhealthy lifestyle. Okay, I'm just going to assume that she means inflammation in this case. Yeah, I'm just going to... Okay. So an unhealthy lifestyle, that's like really broad, because before, what was told to me as a healthy lifestyle was eating plants, and it turns out that didn't actually improve my health. In fact, it didn't do that, not just for me. There's like millions of other people out there who are most likely watching this video. And they will most likely tell you in the comments down below if they ate plants, or when they ate plants, they also didn't feel so good. Or any sort of plant material, they didn't feel so good. Yeah, exactly. There's a reason why, okay? It's because of, one, phytotoxins, which will stimulate an inflammatory response, which is unhealthy, by the way, so you can put that in the unhealthy lifestyle. Also, going through glucose oxidation, in my opinion, not ideal. You don't want your body to be going through glycolysis. You want it going through gluconeogenesis. If you have your body going through glycolysis, you've got some anabolic things going on. And I am, as a general rule, as an adult, I am not really a big fan of anabolism, unless it's related to tissue remodeling or tissue repair of some sort, which I hope you're not going through too much of. But exercise is part of that. And if you're interested in why exercise is actually kind of unhealthy, go check out that video. Once again, found in the Min-Maxing Health playlist. Not super ideal. I don't think exercise is fully unhealthy, but it explains it in the video.
Now, the insulin receptor lock can become rusty and damaged, which causes the insulin key to no longer function to allow sugar into the cell.
You want to know what causes this rust? You see this right here? You see all this green stuff? Take a guess what that is. That's this thing right here. Yeah, that's right. Glucose. You want to know why? Because this chain can snap, and the reason is because this bond is kind of unstable, and what will end up happening is this thing will go, oh, and then it'll immediately change into a straight chain form. Now, I guess this isn't really needed. We don't really need to know this, but the reason why it does this is because it sometimes will go in this alpha form, or this beta form, beta D-glucose or alpha D-glucose. And the difference is literally this bond right here. This is the difference between alpha D-glucose or beta D-glucose. So in this case, this is alpha D-glucose because this bond is, this, as you can see, this OH is going down and this OH is going up. So that means that this is an alpha conformation, and if it was beta, this OH would be going up, which is like sort of steric hindrance in this case. Hopefully you can sort of see what I'm talking about when it comes to steric hindrance. Well, I don't need to get too complicated, but if this one was up, then yeah, this one would be beta. So that's the reason why that chain is becoming rusty. It's because of this thing right here causing glycation, because it's an unstable molecule, and what will end up happening is it will go into the straight chain form, and then it'll glycate that structure, whatever it is. In this case, our little chain here, as she's demonstrating. Now our little chain right here ends up becoming damaged, and lo and behold, now you got some problems. That's why you don't want extra glucose, by the way. So let your body make all the glucose that it needs. Don't give your body extra glucose.
Damaged, which causes the insulin key to no longer function to allow sugar into the cell. Overall, the resistance of insulin receptors as the lock to insulin as the key is the basic mechanism that drives insulin resistance. Okay, so the thing, I would say, one other thing that really dictates insulin resistance is the Randall cycle. So she didn't really talk about this much. So this, she doesn't actually have this part necessarily. I don't know where it was. She talked about it somewhere here. I don't really like the way that she explained this. Like, I think it was like related to this part. So you don't just have one for insulin. You also have one for glucagon, and for fat in this case. And that's kind of a big deal because you can't stimulate both the one for glucagon and insulin at the same time. There's like selective inhibition going on, which means
upregulating one down-regulates the other. Now, you might say, what does that mean? What's the whole deal with the Randall cycle? Basically, if you're stimulating glucagon over and over and over and over and over again, or in this case, you're eating fat, then you're going to use fatty acid as your primary fuel source. And if you're doing this for glucose over and over and over and over and over again, then you're going to be using glucose as your primary fuel source. But if you try to mix the two, and let's say you're eating carbohydrate with like a ribeye, for instance, then you got a problem, because now you're suddenly stimulating insulin with those carbohydrates, in this case rice, and you're stimulating glucagon with the meat that you're eating, in this case the fat. And that's a big deal, because your body is like, oh crap, what do I do, right? So then it starts locking all this stuff outside of the cell, and the reason it locks the insulin, it doesn't lock the insulin. The reason why it locks the glucose out of the cell is because it starts panicking, because if that glucose gets in the cell, it's extremely toxic, like at really high concentrations. So your body has to do something about it, and that's because the mitochondria has the choice between, it doesn't really have a full choice, but it has a preferred choice of either oxidizing fat or oxidizing glucose. And in this case, when you stimulate both of them, it preferably has to get rid of the glucose inside of the cell before accepting more glucose inside the cell. Not ideal. You don't want this problem happening, because it damages the endothelium, because once all of this excess blood glucose gets locked outside of the cell, otherwise known as insulin resistance in most cases, or most people having this high blood sugar problem, yeah, this is why. It's because you're locking both of them outside of the cell. You ate a burger, meat and bread, right? Carbohydrate and fat, and now you got some problems, because you get it locked outside the cell. It damages the endothelium, and it also glycates the endothelium, just like it did with this insulin chain. Not healthy. So I wouldn't recommend doing that, by the way. Don't eat burgers. Either stick to full vegetarian or stick to full meat, and see which one works for you. I'm going to let you know right now, the full meat one works a lot better, and that has to do with micronutrients. Basically, there is no real carbohydrate that you can get that won't cause an inflammatory response as well. There's a lot of problems. There's a lot of problems with carbohydrates. All right, let's go back to the part where you were talking. This one.
Novice level. In your body, you must maintain balance to function and stay alive. This balancing act is known as homeostasis, from regulating the amount of water in your cells to the amount of energy or sugar in your blood. Too much or too little of anything and your cells can and will die.
Yeah, this right here, so anybody who doesn't know, I have mentioned this a couple times in my previous videos. This is basically just how much water exists. So this is, well, water relative to salt concentration. So this is a big deal. So this is basically meaning there's an equal amount or a balanced amount of H2O going in and out. And this is a normal red blood cell in this case. This is a erythrocyte red blood cell. And the reason you know that it's normal, one, not just because it says it's normal, but two, because it's not bursting. If it's bursting, that means there's too much water, right? Which is why, and you can see right here, it shows an H2O going in, like there's too big, and there's too little water in this case. And this is all based on like a gradient. Your body really uses electrochemical gradients. It's really important for tons of functions in your body. Anyways, yeah. So if you don't get enough water, or you get too much water, if you get too much water, your cells look like this. So you don't want that. And if you get, your body's pretty good at regulating it, even with too much water. If you get too little water, your cells will start to look like this. Once again, your body's pretty good at regulating stuff, though. Especially if you're going through fatty acid oxidation, you'll be producing a lot of the water you need. It'll be water generated from the mitochondria, because you'll be going through beta oxidation. But yeah.
Now, to maintain homeostatic blood sugar levels to ensure that your cells aren't starved or overfed, you have two hormones, insulin and glucagon. Insulin decreases
Okay, so I explained this before earlier. Let's see what she has. She got it right.
Blood sugar by telling your cells to feed by binding to insulin receptors on cells, which open glucose channels, allowing glucose to enter and fuel the cell. Conversely, glucagon increases blood sugar by binding to glucagon receptors on the liver, and this initiates the production of glucose, which is shuttled into the bloodstream. Now, due to genetics and life...
Okay, so she's talking about glycolysis and gluconeogenesis here. She didn't really mention that. I'm surprised, because that's like the biggest, that's the most important part about talking about all this.
And this initiates the production of glucose, which is shuttled into the bloodstream. Now, due to genetics and lifestyle choices...
Alright, I swear to God, stop saying genetics, or you get thrown out the window, okay? Like, this is not, it's not genetics. Stop blaming things on genetics. I hate that. When people blame things on genetics, that's usually, if they blame things on genetics and still don't have a solution, that's the biggest indicator that, like, you need to get thrown out the window. If you blame it on genetics, but you have multiple solutions, and they're not prescription medications, hopefully, then, yeah, then I think you're fine. But if they are prescription medications, get thrown out the window. Like, get out of here, okay? You're not doing your job as somebody who's trying to help people with their health.
This is chronic inflammation, advanced glycation,
and products. Whoa. Okay. Does she know that this is unhealthy?
Products, reactive oxygen species, and excess fat or cholesterol can build...
Okay, no. The fat or the cholesterol will not build up. Cholesterol doesn't build up, okay? No. Okay, so I guess we'll explain cholesterol. LDL, what is LDL and what is HDL and what's all this stuff? High density lipoprotein, low density lipoprotein, and then actually the main one for that matter, that is the quote unquote problem that everybody talks about, VLDL. The only problem with VLDL is basically just a carrier of triglycerides. And you might say, why is that a big deal? The reason that's a big deal is because you're going to have high triglycerides if you're eating like meat and carbohydrate. You're going to have high triglycerides if you're doing that. If you're not doing that, you're not going to have that problem. Okay? That's like the only way that you get that problem. Or you could have leaky gut, which could be caused by lectins, once again, a carbohydrate, or a parasite of some sort, or gut dysbiosis for some reason. So once again, no, cholesterol will not build up and damage the artery function. Nope, don't say that. I swear to God, don't say that.
Build up, causing insulin receptors to malfunction.
No, okay? This is not going... Cholesterol buildup is not... Oh, God, no. She even shows Eddie Goki's picture. Bro, yes, carbohydrates are the problem. Okay. This is a lack of understanding of the Randall cycle. I have a very good feeling this is a lack of understanding of the Randall cycle. But in fact, I will guarantee you, let's do something even better than science, okay? Why don't you do personal experience? Exactly. In my opinion, I think personal experience is an even better, usually, and at least in today's day and age, sadly, it's usually a better indicator of whether or not something is right or wrong in comparison to science, because so much science today is fraudulent. So instead of doing all that, go live it out. Go live it out yourself. Try it yourself. Go eat meat only and go eat plants only, and you see the difference in your health. You see the difference in your health. And then start adding those two in together, and then see the difference in how you feel. And do that. Do each of these for about 3 to 6 months and see the difference. Don't worry, you will see a massive difference. I will guarantee you that you will see a massive difference. And if you don't see a massive difference, go join my Discord down below and tell me that you didn't see a massive difference. Because I will guarantee you that you will see a massive difference. You are causing so much less damage on such a huge scale. I mean, I'm not going to explain all of it here, but like she said before, maybe she didn't understand fully all of the details of what she was talking about, but no, okay? There's advanced glycation end products. Where do you get them, okay? You get them from carbohydrates, which is exactly why he says excess carbohydrates. That's the reason why he's saying this. This is the real deal, okay? This is the real problem. It's the excess carbohydrates because of the Randall cycle. Because the Randall cycle says, hey, this insulin receptor and glucose being accepted into the cell, not allowed. That's what the Randall cycle prevents. Big deal.
And when these receptors malfunction, they may stop responding to insulin in the way they should, becoming insulin resistant.
You know how they become insulin resistant? You know why? Maybe because of excess carbohydrates. Insulin inhibits autophagy. Maybe, just maybe, insulin inhibits autophagy. Maybe, just maybe, glucose also does a little bit of problems related to advanced glycation end products and reactive oxygen species formation due to complex 1 being more prone to electron leakage, as well as complex 3, which, great, fatty acid also does contribute partially to it, but even more reactive oxygen species generation comes from glucose oxidation. Once again, and anybody who isn't saying that, I feel like it's bothering me. And not only that, even if you say that it isn't true, then superoxide dismutase is still being glycated. And that means its function is basically being dysregulated. And that's a no bueno, because you got more reactive oxygen species formation, and then your body has to up antioxidant. Like, this is no, okay? Not healthy. There are so many reasons why glucose is damaging. There is like an insurmountable amount of reasons. Fatty acid does not cause the same problem. And one of the main just indicators that you can tell that fatty acid does not cause the same problem is if you look at the Randall cycle, glucose is being locked outside of the cell. Fatty acid is being locked outside of the mitochondria, meaning the fatty acid is being allowed to just stay inside of the cell. And that's a big deal, because that tells you right there that excess fatty acid will not damage the cell. And you might say, why is that? Well, of course, it's because it's unreactive. If you look at this structure before of glucose, well, I guess we'll go all the way back over here. Where is it? Come on. There we go. If you look at the structure of glucose versus fatty acid will basically be this OH. It'll be this OH here, and then there'll be an O here, and there'll be this giant hydrocarbon chain. Basically, it's completely unreactive. It's very difficult to react. And if you look at glucose, on the other hand, glucose isn't like that, because once again, this bond is unstable. This bond is extremely unstable, and it goes between alpha and beta formation, alpha D-glucose and beta D-glucose. Alpha D-glucopyranose and beta D-glucopyranose, technically speaking, formation. And in this case, that is what dictates whether or not it is or isn't more or less stable. And just because it is in this case, this is the alpha form, just because it is in this alpha form, it doesn't mean that it can't swap to beta form, because it can swap to beta form. This is just slightly more stable. Like the steric hindrance still exists. So once again, this is not healthy. Like, you can't tell me that it's not carbohydrates that are the problem. Carbohydrates are definitely the problem. I don't know. Did she show any pictures of fatty acid? I don't think she did. No, she didn't. Well, you can't really see what it looks like, but it's really not that complicated. It's just a giant hydrocarbon chain.
Resistant. And without proper sensitivity to insulin, your cells become inefficient at utilizing their main source of energy, glucose, from the bloodstream.
Nope. No. Okay, see, she says glucose is essential. Oh my God. No, it does not. There is no way she just said, okay. Well, I guess we got her on one thing 100%, because I already have a source for this, and this is found in my Real Nutrition Science playlist. I have sources for all of these. In fact, it's all in the Real Nutrition Science playlist. But this one right here, this is complete BS. So I don't know what she's saying. And the universal fuel of the fetus. Okay, no. If you look at any fetus, or in fact, just look at a baby, even fetuses for that matter. Any of these fetuses or any recently born babies, measure their blood glucose, and you tell me how much they're using glucose as their energy. They're not. In fact, they're not at all. Because if you measure their glucose, you would realize if you got that blood test and you didn't know it came from a baby, you would think that person is either dead or is in a coma. That's it. So this is not possible. Okay? No, fetuses and even newborn babies do not use freaking glucose as the main energy source. They use ketones. And we know that they use ketones because of that Japanese study, which I mentioned in the Real Nutrition Science playlist. No, like, oh my God, this is not, all right. If there is any part I would like to correct the most, or for me to get across in this video to her, it'd be this part right here. This is horse. This is bull. This is complete bull right here. This is not the universal fuel of the fetus. This is definitely not the universal fuel of the fetus. Measure their blood glucose. You give me their blood glucose reading. I can guarantee you it's not glucose, it's ketones. It is so heavy ketones. Ketones are so much, like, there's a reason why the babies want to be using ketones and not using glucose. One, reactive oxygen species formation. Extremely high amounts in comparison to ketones. And how do we know this? The brain prefers ketones. Why does the brain prefer ketones? The brain prefers ketones because, one, glycation exists. Two, advanced glycation end products really screw with the brain. Superoxide dismutase can end up being screwed with, and then the body goes like, oh crap, I don't really have antioxidants in order to deal with all this reactive oxygen species formation. Not ideal again. This is like, there are so many more reactive oxygen species being generated due to complex 1 being more prone to electron leakage. And why exactly might that be the case? It's most likely due to kinetic isotope theory, which is exactly the main problem, because kinetic isotope theory is like, hey, you got some problems here because there is more deuterium in this, which is why glucose actually, one of the reasons why glucose is an even bigger deal, because there's higher deuterium content in glucose. Now, that's a really big deal because all that deuterium basically has a higher chance of reacting instead, or more specifically, basically an extra electron can most likely get added during kinetic isotope theory, get added to an oxygen instead of, that's right, what you want it to be adding it to actually make energy. Yeah, it's not going to do that. Instead, it's going to give it to an oxygen, and then that forms your reactive oxygen species. That's helpful from deuterium, which, by the way, comes from glucose again. So no, it's not. Glucose is not the primary energy source of the brain or the body of any sort. Anybody, there is only one cell in your entire body that absolutely requires glucose, and it's erythrocytes. There is no other cell in your body that absolutely requires glucose. It's like, anybody who's saying this, please. Just measure, if you really want to say something like this, go measure that blood glucose of the baby. And you tell me whether or not that blood glucose is in the high or in the low range. And I'm going to guarantee you it's in the such low range you can't even tell me that they are using glucose as their fuel source. They're using ketones because they come out of the womb. And when they come out of the womb, we already know the Japanese study that I mentioned in that Real Nutrition Science playlist. Yeah, that's right. They're using ketones. They have to.
And they struggle to function properly, let alone efficiently. To conclude, the not energy glucose from the bloodstream, and they struggle to function.
20% of all the glucose in your body fuels your brain. That depends on what you're using. In humans, the brain accounts for 2% of body weight, but it consumes 20%. Okay, yeah. So once again, this really depends on your diet and what you're eating. Once again.
Function properly, let alone efficiently. To conclude, the novice understanding, the buildup of excess fat and damaging waste in the body causes insulin receptors to become
What? Okay.
Goes from the bloodstream, and they struggle to function properly, let alone efficiently. To conclude, the novice.
Okay, so if we look at this, it says insulin resistance. Feel tired and hungry. You're not going to feel tired and hungry after you eat, by the way. That's not normal. The reason why you feel tired specifically comes from orexin. And what exactly am I talking about with orexin? Orexin is a hormone that basically dictates alertness. And what are you doing when you're eating glucose? You're inhibiting orexin because glucose inhibits orexin. So stop eating glucose and hungry. And once again, you're not going to feel hungry if your leptin is actually properly regulated. If your leptin is improperly regulated, then yes, you're going to feel hungry. And if you stimulate ghrelin, which is what you do with carbohydrates, then you will feel hungry. If you don't do that, you won't feel hungry. Like me, I don't feel hungry. And for that matter, tons of other carnivores out there don't feel hungry because of this. And they don't feel tired after they eat also, by the way. Eat food, make insulin. Cells resist insulin. Sugar stores as fat. Where do you get this? Where are these sugars coming from? That's right. They're coming from glucose. Whoa! Crazy, right? Yeah, so just like, come on, man. Read your own chart if you're gonna put something out there like this. Where does this come from? This doesn't just appear out of thin air. Okay? It comes from glucose. So stop eating so much glucose. There's also something called gluconeogenesis. Instead of going through this process of glycolysis and messing up your body because you're constantly gaining weight, like this, because once again, glycolysis promotes anabolism. Yeah, go through gluconeogenesis. Start eating meat. Just test it. Test it yourself. Don't listen to the science behind all this. Screw the science for that matter. Say screw the science and test it yourself and see if it works. It's not that hard. Really not that hard. 6 months, you just try it for 6 months and you see if it works. 6 months, eating only meat. 6 months, eating only vegetables and fruits. 6 months, mixing them both together. And you see how you feel and record how you feel. And notice this part real quick, by the way. You won't feel tired and you won't feel hungry doing this carnivore stuff. Because you can't. It's so difficult to. It's near impossible because you're stimulating leptin to the high heavens.
Understanding the buildup of excess fat and damaging waste in the body causes insulin receptors to become insulin resistant. And finally,
and how do you get that?
Fat and damaging waste in the body causes insulin receptors to become.
How do these insulin receptors become insulin resistant? Okay, once again, this is just a term made up by us. Like, this insulin resistance is basically just the body being like, oh my god, there's so much glucose in the bloodstream. Oh my god, I cannot accept this glucose. And once again, this is Randall cycle dependent. So, and also it's glycation dependent. So stop eating so much glucose.
Become insulin.
I like advanced glycation end products, which is literally what she mentioned. So at least she knows that. So she knows that. Like, I don't understand why she isn't like that. That would, well, I guess you would have to know a lot more prerequisite information. Anyways, that's besides the point.
Resistant. And finally, nerd level. In healthy physiological states, insulin binding results in autophosphorylation of the insulin receptor, initiating downstream cell signaling that elicits either a mitogenic or metabolic response, depending on the concentration of insulin in the bloodstream.
Yes.
When insulin concentrations are high, SHC is recruited to the phosphorylated insulin receptor and triggers a mitogenic response by the MAPK-ERK pathway, leading to growth and mitosis.
Okay, so she's basically just saying anabolism. I mean, I don't know why you wouldn't just like keep it simple like that. But okay.
Conversely, when insulin concentrations are low, insulin receptor substrate molecules, IRS molecules, are phosphorylated by the insulin receptor. Next, IRS1 recruits and binds to the P85 subunit of the PI3 kinase, and this activates the P110 catalytic subunit of the PI3 kinase.
Okay, this is not nerd level. Like, this is not necessary. Okay, you don't... In my opinion, there is no reason... Personally speaking, you should never memorize these numbers and stuff, because if you don't already know, these numbers are sometimes assigned to other things in biology as well. They'll just like say the same thing, which is kind of it makes things way more confusing than it needs to be. So not ideal. But yeah, I really wouldn't recommend this stuff because it's really, really annoying.
which acts on a molecule attached to the cell membrane called PIP2 and converts it to PIP3. Next, PIP3 recruits PDK1, which indirectly activates mTOR, and together mTOR and PDK1 activate the...
Okay, so when she's talking about mTOR and stuff, so this is... Alright, mTOR... What's that? So there's going to be a lot of hate against mTOR, man. She's talking a lot of things at once in this. I would really rather just explain this. This is only a 3-minute video, and it's already being forced to be so long. Jesus Christ. Anyways, so mTOR, there's a lot of people who are like mTOR's bad or whatever. Okay, mTOR comes from two things. It comes from IGF, which is insulin-like growth factor, or it comes from, hopefully you're not getting so much of it from this, but it can come from this. Doesn't really matter though if you are getting it from this, because if you are getting it from this, there's a pretty good chance you're actually eating correctly. That's meat. Well, it's actually leucine, but it's an amino acid. And you might say, why is that a big deal? Because mTOR is the thing that dictates, in this case, it helps build things and stuff, which I guess she might explain here.
The AKT or PKB molecule. From here, things start getting exciting. The PKB-AKT interacts with a protein called AS160, the essential Rad gap involved in the distribution of GLUT4 to the cell membrane. Once the GLUT4 storage vesicle is transported and integrated into the cell membrane, glucose is shuttled into the cell via GLUT4, the glucose channel. Now, unfortunately, due to genetics and lifestyle,
I'm gonna throw her out the window. I swear to God, she keeps saying that.
Accumulation of DNA methylation, intramyocellular lipids.
Okay, so this DNA
Due to
methylation.
genetics and lifestyle, the accumulation of DNA methylation.
Okay, so she says DNA methylation. This stuff, like, this is one of the one of the ways that people measure aging. I don't necessarily know if this is an accurate way of measuring aging, but just to let anybody know who doesn't know out there.
Methylation, intramyocellular lipid, and receptors like RAGE being active.
Okay. Once again, this right here, ages and rages, take a guess where this comes from. It comes from glucose. Why? Because this is literally advanced glycation end product. Ages and rages, if you don't. Yeah. Yeah! She's literally citing it. Okay, now she's driving me crazy. I don't understand. Okay. Bear with me here. I'm so confused. Well, she hasn't said if she's carnivore or not, but based on all of this, she seems to be like... Earlier in these two, she seemed to be sort of in favor of saying glucose is the main fuel source. But then she shows this right here, which is literally her source showing that glucose as the main fuel source is unhealthy. Advanced glycation end product. Okay, we'll just read this out. Advanced... This is frustrating me. She's like Dr. Mercola or something. It's like Dr. Mercola literally said all of this stuff in favor of carnivore and then suddenly just is like promoting fruits and vegetables. Like, what? Like, you're saying, you're giving the science behind why carnivore works, like literally with this sentence right here almost. Advanced glycation end products are proteins, nucleic acids, or fats that have been glycated. Sugar is attached to them. Role of advanced glycation end products, AGE, in obesity-induced adipose tissue inflammation. Like, I don't know if she knows. Oh, she's frustrating me. She's frustrating me. She's doing the Dr. Mercola. She's proving carnivore is right, and then she's saying it's wrong or something. She's like proving that glucose is the main fuel source, and then she's proving that it's not. Like, it's one or the other, and we both know this is a big it's not genetics. This is not genetics. This is lifestyle, okay? Glycated. Sugar. Where are you going to get that sugar? That's right. You get sugar. What is sugar? Oh, wait. She'll spell it out for us real quick. Sugar equals glucose. So why would you be using glucose as your main fuel source? You just said over here, it's not healthy. Okay, this is what I mean. I'm going to say this right now. This applies to and I really do mean every single scientist out there. Learn how to use your brain, because all you've been taught in university is you've been taught to memorize. You haven't been taught how to use your brain. I don't care if you went to university and you became a doctor. I don't care if you went to university and you have a PhD. It does not matter. Your accreditations are worthless because if you can't see it right here, this in my opinion, this is very sad to say once again, this is a great example of being unable to put 2 and 2 together. This is the best example that I can think of. You have just given me even more reason as to sugar being the culprit and the problem of all of this. And you say it's not. You say over here, glucose is the main fuel source. Yet over here on the advanced version, you suddenly say this. So this is the Dr. Mercola, where Dr. Mercola was like, what did Dr. Mercola say? He said something with like polyunsaturated. Yeah, that's right. Oh my God. He said, hey, you're going to only get healthy fats, by the way, from plant fats, and that's because they have this conjugated linoleic acid in them, this CLA. And then if you look at that statement, you're like, what is he thinking? Conjugated linoleic acid is found in much lower quantities in plants. It's found in meat. So he even proved indirectly by accident that carnivore is healthy because he said you're getting more conjugated linoleic acid. But he didn't know where you get more conjugated linoleic acid. And once again, this is a lack of being able to put 2 and 2 together. You cannot say glucose is the main fuel source and then you just cite this source right here. Okay? This is a complete lack of critical thinking and putting 2 and 2 together. You have to be able to put 2 and 2 together. And if you can't put 2 and 2 together, which you can't in this case, because if you're saying glucose is the main fuel source, once again, I'm going to say this over and over and over again because it bugs the crap out of me. And this is going to be a problem, I think. If university and academics actually see this video and then they see what I mean by people, including themselves usually, cannot put 2 and 2 together because they say glucose is the main fuel source and yet they cite a source like this, there's like, that's contradictory information, okay? You can't say the fetus uses glucose as the primary fuel source and then you suddenly cite this source. Like, that's not how it works. If the fetus was using glucose primarily, well, it wouldn't. But if it was, that fetus is going to end up with a lot of genetic problems, from as we can see, because I think there would be a lot more glycation during that whole process. Ooh, that does not sound good. That does not sound good. Anyways, besides the point, this is, once again, I don't care if you go to school. If you go to school, it's completely irrelevant. If you get a PhD, it's completely irrelevant. This is why... Oh, God. I'm going to say this right now. This is the exact reason why we're not having a scientific breakthrough, I think. And it's because of this. It's the lack, it's the education system is so poor, it doesn't teach people how to think. It teaches them what to think. So what does she think? She thinks glucose is the primary energy source. Sugar is equal to glucose, and this is the primary energy source. Yet if she knew how to think, she would come to this source she literally cited. Where is it? It's like somewhere here. She would come to the source that she literally cited right here, and she'd be like, oh, I'm wrong. Like, I admit that I'm wrong in my videos sometimes. Well, I admitted it in one of my videos. I can't remember which one. I think it was the height one. Yeah, you don't, by the way, if you did watch the height video, don't use the inversion table. There will be side effects occurring, which you don't want. You can use it, but you don't want the side effects. Trust me. Once again, learn how to think, not what to think.
Activated may occur, which interferes with the metabolic signaling cascade and prevents GLUT4 channels from being transported to the cell membrane. Overall, with broken metabolic signaling, GLUT4 is not transported to the cell membrane and insulin resistance occurs. And on that note, I hope you now understand insulin resistance a little bit better than before. If you enjoyed the video or learned something new, make sure you like, subscribe, and comment down below another topic you'd like me to explain on the noob, novice, and nerd level of understanding.
Okay. That's frustrating. All right. So I'm going to say right now, that's frustrating. That's really frustrating. This is what I mean. This is a lack of critical thinking. Like, okay, where does this lack of being able to put two and two together or critical thinking come from? I actually think it comes from a couple factors, I'm going to say right now. No hate on her. Once again, I don't hate any of these people. Main things that I think contribute to this lack of being able to understand like critical thinking and stuff. One is application. So I think, in my opinion, one of the best ways to increase your level of critical thinking, I know this is going to sound crazy, play video games at an extremely high level, or do anything at an extremely high level. Like in my case, it's League of Legends. So I play League of Legends at challenger level. It's extremely difficult. That will teach you how to critically think. You'll be forced to critically think. Trust me. You have to. You have no choice. There's no other option. And that has to do specifically with basically rewiring your brain to prove itself when it's wrong. I'm not going to be explaining that in this video. Second thing is sleep. You need sleep if you want to do this. Third thing is, for that matter, a abundance of information. So you need to know a lot more information in order to do all of this critical thinking in the first place. You need to be able to take from tons of different sources and tons of different places, one or the other. So yeah, once again, thanks for watching. If you found the video helpful or informative, please like, share, subscribe, comment down below, because it really does help the channel grow. And if you're interested in joining the Discord, go join it. Link in the description. So yeah, go join the Discord. Tons of people there. There's like 100-some people there or whatever. So you'll get to meet a lot of other like-minded people like you. Yeah, I think that's it. Oh yeah, and if you're interested, once again, I'm going to say this over and over again because this stuff is amazing. This stuff works better than prescription drugs, in my opinion. If you're interested in Cerule, go click my link down below and go get Cerule. Buy it under my name so I can go get free stuff for myself because I use this stuff all the time. Thanks for watching, guys. I'll see you in the next one.